In this final demonstration video, I want to show you how you can run different languages in Jupyter Notebooks and even multiple at the same time, how you can use multiprocessing to try to speed up your code, and finally I'll give you a quick demonstration on how you can set up a GitHub repository. So I will not type out this code entirely because I just want to show you that this is possible to kind of spark your curiosity to explore this further, which is that Jupyter Notebooks are inherently language agnostic. Now, majority of people will use them with Python, but that doesn't mean that you cannot use them with different languages. You can see here at the top that this says Python 3, but it does say switch kernel if I were to click on it. And in this case, I don't have other kernels installed, but let's say I have an R kernel installed, I could switch this to a different language. Generally, I don't like to use it that way. I always have these as Python notebooks, but then whenever I have to use another language, let's say R, let's say Stata, I would then use a package that will enable me to specify some cells as that specific language. So I have a demonstration here where you will use the package that I've developed many years ago, 4 or 5 years ago at this point, which is called HighByState. Now, this HighByState package does not come pre-installed with the environment that you're currently using, so you'll have to install it by just Google HighByState. You'll find a GitHub repository, and there's certain setup steps that you'll have to follow as well to get to this point. An interesting fun fact is that at the Stata Conference 2020, which is going to be in about a month or so from when I'm recording this, they're actually going to give a presentation about their native solution that will also allow you to do this because it's tremendously useful. So I'm very excited that they are getting to the point where they're actually officially supporting you to use this without having to use my solution. The way that this would work is you would set everything up and then you would import this package. So I'm going to import HighByState, and then I can use cell magic, which is indicated by this %%. And I can say %% Stata to indicate that I want this to be a Stata cell. And then I say, well, just run this Stata code for me. So display hello input by Stata. So I run this, and now in the background, it's going to actually run this code in Stata and then give me the output back. This is not super impressive, obviously, but let's say that we want to use the auto data set that comes pre-installed with Stata. We can add some parameters to this, where I say I want to get the output and I want to save this output to a pandas data frame. I want to call that data frame AutoDF. So I run this Stata command, and then at the end, whatever is left when it comes to the data set is then going to be converted into a pandas data frame called AutoDF. So I can run this, and now voila, I have a data set that was created in Stata, then moved into Python and converted into a pandas data frame. And I didn't have to do anything for that. Just to prove that there's actually a Stata installation here, and it's not just magic, I can do bar-os. That's going to then reveal the Python client for me, and you can see here that this is all running in the background, and I can even interact here if I wanted to. Or I can start combining Python, pandas, and Stata together, where I say, well, let me use pandas to create a new column, and this is just basic pandas, and then I'm going to send this data frame by doing bar data AutoDF. I'm going to send that into Stata, replace the current data set that's in Stata with this data frame, and then use some Stata commands on it so I can run the summarize command on this new column that I just created that didn't exist before. And I can just kind of work back and forth. I send data into Stata, I do something, pull it back into pandas, do something with pandas until I'm satisfied. This is generally how I do most of my analyses. I will have pandas data frames as kind of my core data frame, or my core data structure, and then I would, in a notebook, use these commands in order to run my statistical analyses. You can do the same thing with R, but then obviously you're going to run R commands and not Stata. So the second thing I would like to show you is that sometimes when you run code, in particular something with a substantial loop, it can take a while for that to get completed. There are ways that you can try to speed this up. Python doesn't do this by default, and you'll have to kind of specify that you would like to do this. More specifically, what I'm talking about is multiprocessing. Multiprocessing means that your computer might have a CPU that has multiple cores, or multiple threads for that matter. By default, Python will execute everything in one core, or one thread, I should say. But if you have more of these threads available, then you might be able to kind of split up your execution by saying, well, I want this core to work on this core to work on that. And that might be able to speed up your code quite drastically. This can be pretty complicated to do, but what I recommend is to look into the joblib package because it's really nice and it allows you to do some of this in a very convenient way. So I will import this. And let's say I have an artificial example here where I have a list of numbers, 60, and I have a function that I would like to apply to every number, which is just sleep for half a second and then multiply by 2. If I now were to run this, normally without specifying any multiprocessing, it's going to do them one by one. It's going to calculate it, sleep half a second, calculate it, sleep half a second, until it's done. So if you were to run this, it's going to take about 30 seconds, right? Because we have 60 of them and each of them will have a sleep of about half a second. So we see now this took 30 seconds to complete. I used this cell magic time in order to put a timer on how long this took to execute so that we can compare. Now what we can do is, as an alternative, because this is a very parallelizable task, because it doesn't matter what the order is of any of this, we just want to apply that function to all of the different elements in that list. We can use this joblib package and then more specifically the parallel function and the delete function. You don't really need to know how this works. Just remember that this is how you do it. We can say, well, we want to parallelize this. And we do the number of jobs. -1 sets it equal to the amount of cores. We don't have to specify. We can say 2, 4, 6, whatever. But -1, we'll just use them all. And then we want to apply the test function. And then we want to loop through the different numbers. So if we were to run this, we can wait for this to finish. So we can see that this now only took 3 seconds to complete versus 30 seconds beforehand. And this is because I have 12 threads in my machine. So it was able to speed it up by a little under 10 times. I was able to parallelize it on 12 threads. So it's not 100% one-on-one 12 times speed up, but it gets pretty close. So if you have to run something many times or you have to a long list that you want to loop over, feel free to look into this joblib package because it might be able to save you a very substantial amount of time. The last thing I want to demonstrate is related to version control, and I want to show you how I would generally go about creating a new GitHub repository. So what I would do is I would always start by going to GitHub, and you need an account, obviously, but once you have that, you're logged in. Then you can see here, there's a big button that says New. You have some information. Let's give this Limburg test repo. And then we can specify whether we want this to be public or private. Let's say we want this to be private. And then we can click Create Repository. And now we have an empty repository. Now, the reason I recommend you to start with this step is because we can now move this empty repository to our system, add everything into it, and then update it just so that we don't have to deal with any inconsistencies or anything. So we now have this repository. Then we would open up our GitHub desktop client. We would go to File. We would add Clone Repository. We would filter our repositories and we do Limburg test repo. We can specify where we want this to go. So let's say we want to put it right here. Then we click Clone. Now what this is going to do is going to create a new folder inside of the folder that we specified that will have all the details included to this. And most of the time we will not even see this because this is a hidden file. But that will just say that the GitHub desktop client knows that it needs to look for changes in that particular folder. So if we go to that folder, then we now see that we have a folder that says Limburg test repo. And if you have it set up so you can see hidden files, you will see right here that says .git. You don't want to delete this because if you delete this, then the GitHub desktop client no longer knows that this folder is linked to that repository. And then what we can do is, in this case, because we don't have anything in it, we cannot click publish. But let's say we want to add a quick demo test file. And let's just add something to it. Right there. We save this up. And then if we now go back into our GitHub desktop client, we can see that we have this file here. Now, one word that might be relevant for some of you, if you want to move an existing project into GitHub, then you would follow these same steps. But then at this point, you would just copy the contents of your other folder into this folder and then follow these steps. In this case, let's say we don't have anything, so we specify this. And then here we need to create a commit that says we want to register these changes. And we say, well, we created a first file. We click commit, and here you can see that you can check the files that you do or do not want to include. And this is also if you have a gitignore file, that anything that's in the gitignore file will not show up here. And then you can see you click commit to master. Now, if you do this, it's not yet going to be displayed on GitHub, because if we show here and we refresh this page, it's still going to be empty. And the reason is that we did create and we registered the changes, but we did not yet send it to GitHub. So if we want to do that, we need to click publish the branch. And if you do this the second time around, it will say sync, as I will show you in a moment. So now it's pushed that, and because it was the first time it said publish. And now if we refresh the page, we now see that, hey, we have this text file here. And this text file does indeed have that hi there that we put in there. And if you were to change this text file, let's say we want to say, hi there, my name is Thies. We save this up again. Now, if we were to go back into our GitHub desktop client, we see that it has noticed that we have made a change to this text file, because it has say, well, it added this new text. So we can say, well, added name, and then we can click commit to master. And then here it says push to origin, and this is what it will say for any time that's not the first time. First time we'll say publish, after that we'll say push origin. So you click this, and then it's again going to send it to GitHub. It does all the reconciliation to make sure that it records all the changes. We click here, and we see here there was a change made 22 seconds ago. We have 2 commits. We can click on this, and we see all of these different changes that we sent to GitHub. And then if we were to click on this one, we can see that we modified the hello.txt file, and we changed it by changing the text by including this my name is Thies. And that's essentially the gist of it. Now, the only thing is that if someone else were to also be working on this GitHub repository, then you would have to make sure that every time you start working, you would go into the GitHub desktop client and you would click fetch origin. What this will do is we'll make sure that whatever you have locally is going to sync up with what is currently in the GitHub repository. So that means if someone else made changes, then you're going to fetch the origin and you're going to pull these changes into your repository. If it finds any changes, it will say pull, which essentially means download, and then you would click pull, and then it will load everything in, download everything. And then you will have the most up-to-date version locally. And then whenever you're going to make changes, you will not run into the problem of any merge conflicts where you change something, but someone else also changed it, and GitHub doesn't know which of these changes it should kind of follow. So if you keep everything up to date and everything synced, then that generally does not happen. So I have a problem markdown file that's on GitHub in day 5. And in that problem file, it will ask you to follow some steps to solve some problems. Most notably, it will ask you to make your own GitHub repository, do some changes, work with your group members to kind of sync changes between your different computers. And then I look forward to our happy hour after this.